Okay, so in this video we are going to find the force that would be needed to bring about a change in the velocity of an object. So question is here that we have an object having mass of 2 kg and it is moving in the east direction with a velocity of 23 meters per second, and after 3.1 seconds the object's velocity changes to 23 meters per second but in the north direction. So this, because there's a change in velocity, it cannot have come about without application of force. So some force must have acted upon this object and which changed the velocity of this object. In other words, we need to say that because the velocity had changed, which means that there was an acceleration, and acceleration cannot come without application of force. One thing to keep in mind here, that the magnitude of the velocity is same, or in other words, the speed is same, 23 meters per second. But because velocity is a vector and object's direction of movement has changed, earlier it was moving in the east direction and now it is moving in north direction, it means the velocity has changed. Speed might be same, but the velocity has changed. So as we discussed in the previous video, there are two ways we can do this. So we'll be using the first method here, and that method is we'll be using this equation F is equals to m times a, and m can be written as v minus a. Sorry, let me not write that. So in this, to use this equation, we need to first find the acceleration. Yeah, we can find the acceleration here. So acceleration is equals to, I'll write that as a vector, v minus u divided by t, or delta v upon t. So we need to find delta v first. Yeah, I forgot to mention that we need to always list the quantities that are given. So that's the first thing basically you do, and I'm going to mention the quantities now. So it is 23 meters per second, and this is moving in the east direction, so I'll show it like this. V is equal to 23 meters per second, and because it is moving in the north direction, so I will show it like that. And then you got t is equals to 3.1 second, and I need to find delta v first, which is v minus u. Now v minus u I can write, if you recall from the very first video, I can write v minus u as v plus minus u. So what I need to do is I need to add the vector v with the reverse of the vector u. Okay, so let's draw those vectors first. My vector v is equals to 23 here, and u is equals to 23 here. So minus u is equals to, the length remains the same, the direction has changed. So I need to add this vector and that vector. Now vector addition we are all familiar with, so I will quickly do this. So this is v, I have drawn like this, and that is my minus u, and this is from starting point to the end point, so that is my delta v. I can use Pythagoras theorem here. So delta v, magnitude, the length here, the length of this vector here is equal to square root of 23 square plus 23 square, which basically is 32.53 meters per second. Then I need to find the direction as well. I call this direction as theta. So theta is equals to tan inverse opposite over adjacent, 23 over 23, which will give you 45 degrees. And that will tell you that my delta V as a vector now is 32.53 meter per second, and the direction is from north 45 degree towards west. I got delta V. Now I just need to divide by t using this equation here. Using this equation, I need to divide by t to find acceleration. So acceleration is equals to delta V upon t. Delta V is 32.53 meter per second north 45 degree west, divided by t is 3.1, and that gives me acceleration of 10.49 meter per second north 45 degree west. That's my acceleration. All I've done is, this is the magnitude here, and that's a number time is 3.1. I just divide 32.53 by 3.1, and here that direction is carried as it is. So this is my acceleration. Now I use the first equation here. F is equals to ma. I'll write that as vector. F is equals to m is, we got 2 kilogram, and acceleration is 10.49 meter per second north 45 degree west, and that gives me a force of 20.99 Newton in the direction of north 45 degree west. So this much force was needed to get this change in velocity. Now we are going to solve it using momentum. So I'll just scroll it up there. I got the question here again, and we are going to look at this equation now. I'm going to just write the equations that I'm going to use. F I need to find as delta P over T. To find delta P, I need to do P final minus P initial. Yeah, and again the quantities that are given are, so m is given as 2 kilogram, u is equal to initial velocity is 23 meter per second, u east, v is equals to 23 meter per second u north. So pi is initial momentum, which is m times u, which basically is multiply m2 times 23 meter per second like this, and you get 46. This is 2 kilogram here, 46 Newton second in the east direction, and likewise PF is equals to 2 times 23 in this direction. That gives you 46 Newton second in the north direction. Yep. So now to find P final, to find delta P, we need to do a subtraction. So again, I'm just going to write like I wrote in the previous case. So delta P is equals to P final minus P initial, which I will write as P final and negative of P initial. Now I will draw these three vectors. So first one is my Pi is equals to, I don't need to say equal to, I just clean that thing up. Pi is 46 Newton second in the east direction, so that is, this length is 46. So minus Pi is, you keep the length same, but change the direction. That's my Pi. And Pf, that's my final momentum, is equals to, just given here, length is 46, but it's in the north direction. So we need to add Pf with the negative of Pi. So I need to add this vector and this vector. Now vector addition we already know, so I'll just draw them. That's my, and the order doesn't matter in vector addition. I can draw that pi minus pi, this vector first, and that later, that second, doesn't matter. It will not change the answer. So you got 46. This is my pf, and that's my 46 pi. This is my starting point, and that's my end point. So that's my delta p here from this equation. Yeah. Using Pythagoras theorem, we can find delta p. So delta p is equals to 46 square plus 46 square, which gives you, just use the calculator, 65.05 Newton second. At this stage I should basically remove the arrow there because I'm just talking about the magnitude here. And to find the direction, I need to say this angle is theta, and I need to find that angle as well. So let me write pf bit here, and that's my theta. So again, I can find that theta is equals to tan inverse, which is equals to 45 degree. And with that, I can write my delta p as a vector. Delta p is equals to 65.05 Newton second, and the direction is, you can see this is the north direction, and from the north we are moving towards the west by 45 degrees. So north 45 degree west. Now once you got the delta p, we can now use this equation, the very first equation, to find f. So f is equals to delta p over t. So delta p is 65.05 Newton second north, 45 degree west, divided by time is 3.1. And just plug in the calculator and you get your answer, 29 Newton second, 20.99 north, 45 degree west. So again, we see that the answer is same. Obviously it has to be same. In the previous case also, when we used F equals to ma, we found the same value of force, and we use different approach. We use change in momentum, the concept of change in momentum, and we found the force here as well.